Hello and welcome to another Wednesday. We have a guest today again as well, and we actually have a few things to talk about, but we wanted to do a deep dive on the subject matter that our guest is about. I just got distracted because he actually brought a dog, so that was more important than anything else. So that's the problem there. How are you doing,
Yeah,
Danny?
I'm very well. Yeah, I'm better now. We've had a little surprise dog on the backstage show. So yeah, I'm very well though. I'm hot. I've said that for the last few months, but I'm sick of it now. I think end of August, give me the rain again. It's about time for the rain in the UK.
I told you it's the other people's task to call you hot. You can't call yourself hot for a month and believe the world to actually believe you to go for that. That's just wrong. And I mean, if other people call
Self-love.
you hot in the office, that's also inappropriate. So I think, yeah, we have to talk about that. That's just not right.
It works for me, maybe I'll just say it to myself in silence. That's what I'll do. But other than that, no, I'm very well. I'm looking forward to today's show. And yeah, Wednesday always comes around quick. We've done a lot of well, we might as well just actually mention at this point we've been sort of in a hole for the last month, haven't we, editing all of the talks for the World Congress. And at the end of last week they've all gone live. So anyone who's watching this now who might have done a talk at the Congress, go and find yourself. It's going to be shared on socials. But yeah, just that's kind of letting people know where we've been, I suppose, for the last few weeks.
Yeah, and we got a new interface coming as well, where you can actually search for topics and show you like different URL, different parts of the video as well. So that's something that we're cooking at the moment. So I'm trying to get the internal engineers like Tom and Tom to actually do a TomTom show with them, to actually do a coffee with developers, so we can actually show you what we're doing in this regard, because I found it very interesting, and it's an exciting thing to make video a long form content that you don't have to watch. Because that's one problem that I find with longer videos, that people just don't watch them, and it's a lot of work that we put into editing them. It's a lot of work for writing the talks and giving the talks, and then nobody goes for it afterwards. So that's really bizarre. So we try to find a way around that a bit. But yeah, I mean, we have somebody on the show right now, and Vince is actually the guy who's doing the tech here. Vincent, he was just showing it really quickly, so we have to edit that one out, I guess. But yeah, we have Raphael de Lio here. And you are from Redis, right?
That's correct.
And yeah, that's about all that's interesting about Raphael. So thanks for being on the show.
No, I didn't understand. It was my cue to introduce myself. I'm so sorry. But my name is sorry about that. My name is Raphael de Lio. I've been working as a software engineer for the past 7 years, mostly in the JVM side, but now also doing some stuff in Python, as I'm about to show in the talk today. Last year, I joined Redis as a developer advocate. I was already doing that job for free, apparently, because I have also a personal YouTube channel where I was talking about Redis for a couple of years before they actually noticed me and said, hey, do you want to get paid to do what you're doing for free? And that's how I got here. So I've been here for 10 months now, almost a year. It's been quite a nice journey, enjoying it very much, and looking forward to the show today and to the talk that we're going to have.
Well, I guess that is the cool thing about open source, isn't it? Like, I mean, I had that when I worked at the Yahoo libraries and the Microsoft stuff as well, that it open source, that you can hire people that already are experts in your subject matter because they were excited about the product. And that also makes job interviews super easy because you already know what people have done. And when they contributed to the core, even better, and you can look at how they deal with people's pull requests and how they deal with people's comments on GitHub and other channels as well. So I found out more about how much of a team player they can be even before they got into the interview, which actually rushed the interview process much, much more than just like, who are you and can you introduce yourself? Because that was always awkward.
That's true. And you have a couple cases inside of Redis. I don't know how many. I know a few, at least, that came from the open source community directly into Redis. Some of them were building client libraries, for example. Or in the case of myself, I was doing community work. Have other people doing community work who just hired the person behind the Redis Stack Exchange tag as well. So that's true.
Stack Exchange. Whoa, I haven't heard that one for a while.
Yeah, me neither. Yeah, there's actually a book, I don't know if you guys have heard of it, that is called Show Your Work. I have it somewhere here. It was written by a guy called Austin Kleon. And this is the book. And the premise of the book is basically you can be the best at what you do, but if you do that in your basement, nobody's going to notice you and nobody's going to hire you, right? So that's one of the reasons why I started sharing knowledge online with my YouTube channel and also my Medium blog and other means of communication as well, because I wanted to get noticed and I wanted to get new opportunities such as the one that I got today. Just
yeah, I mean, when I wrote the Developer Evangelism Handbook or Advocacy Handbook, that was the same thing where I just explained to people my biggest success was basically asking questions at conferences. Like, I mean, I was one of my first conference was 2004, and that was basically a PHP conference in Amsterdam. And then in 2006, there was a conference in London, 2005. And I had begged my boss for months and months to actually get me a ticket to go to that conference because I really wanted to. And I was the lead engineer on the project, and I never ever did anything community-wise. And I was like, okay, that's really bizarre. And I went to that conference and asked every single speaker a question about the things because I wanted to get my money's worth. But and somebody came up to me and said, like, hey, you know all this, why aren't you speaking? And I'm like, because I'm actually working, and I got like 10 people reporting to me, so I've got no time for that. But yeah, and he's like, what do you think about writing a book? And I'm like, okay. So that's how I got my book contract, by asking questions at a conference for other speakers. And none of the other speakers got a book contract, so that was unfortunate. But I think it's interesting that you by asking the right questions and by being interested in things, you actually get visible, and that's a very important thing to consider. And it's a scary thing as well, especially when you're not a white dude. Then there's a lot of like negative backlash as well, sadly enough, still. But I think it's a very important step to actually make you realize, like, it's if you have a good boss, if you have a good manager, then they actually will tell the other people about your work. But most of the time, it's up to you to do that. So, Danny, sorry.
Yeah. No, it's true though. I mean, just on that, it's like I thought about, you keep seeing the word like yapping, online, like people who talk a lot, and they obviously just get a lot of engagement, they get a lot of attention. But there's like people out there quietly, like yourself, when you're saying that, Raphael, like the people out there that are just making amazing content like consistently every single day, and it's like a long game, isn't it? It can take years for them to get that goal, and that goal might even be like a fuzzy goal, like you hoping to get picked up by Redis. And it's like it really, the only way you can kind of maintain it is like the love for what you're doing, and the passion comes through. And I think then if you're hiring that person, it's like, well, okay, we've got the building block. They love what they do, and they love this product in particular. So it's like a win-win for everybody, isn't it?
Yes, totally. And also when I started this project myself, like this personal project of sharing knowledge, I didn't know what I could expect from it, right? So at the moment last year that the person who's my manager now got in contact with me and said, hey, we're thinking about hiring you. Would you like to take part in the process? I was super happy, not because I didn't know if I would pass the process and I would actually work for Redis, but I was super happy that I was able to actually prove the premise of the book, right? That it actually got me the opportunity. So this was a really nice part of it, indeed.
Yeah.
Sometimes it's also being a stick in the mud. I mean, what I loved about when I got hired by Microsoft, they pointed out one thing I've done. I was working for Firefox back then, for Mozilla, and Microsoft in Internet Explorer 8 had like a demo for St. Patrick's Day, where they had like shamrocks as like particle systems, and it said like, okay, Internet Explorer 8 is that fast, Chrome is that fast, Firefox is that fast, so Microsoft is the best thing, and Internet Explorer is the best browser for it. And I looked at the source code of that thing, and for some reason there was in the background a gradient from FFF to EEE that switched around every 2 seconds. And there was just basically saying like gradient switch was the function name. And I'm like, what the hell is that about? Like that it's not visible. It doesn't make any difference. The difference was that Internet Explorer was back then the only browser on Windows that was caching gradients in CSS. So basically, it didn't do a reflow for every gradient that all the other browsers did. So of course, Microsoft Internet Explorer was about 5 times faster than all the other browsers. So I forked that thing, took out the gradient swap thing, and then did an analysis of all the browsers, and it showed that Firefox and Chrome were much better than Internet Explorer. And when then they contacted me and said like, hey, we're actually thinking about making that browser Edge, and sorry for finding these things out, but the effort that I put in to prove them wrong actually was, to me, half of the interview to get started at that company. So being the one that points out obvious marketing horseshit is sometimes a really good thing.
That's true. Yeah, I have a similar story actually that happened last year, because there are a couple of people advocating for using Postgres for everything, right, including using Postgres as a cache. And I came across that last year, and I was like, does it really make sense? Especially because I was listening from a lot of people from Redis at least. Before I worked at Redis, I was already in contact with a few of them, and they were advocating for using Redis as a primary database. And I was like, okay, now we have a clash here, right? Because we have people advocating for using Postgres as a cache, people advocating for using Redis as a primary database. And because of that, I started doing some benchmarks and understanding how Postgres actually works under the hood as well. And then I wrote an article about that and explained why it didn't really make sense. It may give you a little bit of more performance, but nothing compared to Redis, mostly because of all the guarantees that Postgres give you with the asset properties, for example.
Mm-hmm. So that's Postgres. Is there also getgres and updategres and all the other HTTP commands? No. Okay. Oh God.
That's the first time I've seen even you have that reaction to Chris to one of your jokes. That's great.
I did the same with Post Malone, if there's like get Malone and these kind of things, and delete Malone. And
Oh, that's funny.
no, HTTP is fun.
But the funny thing is that it started saying these things. I was like, what is he talking about? I don't know this technology. Is like upgrades? Is this like some cache based on Postgres?
That's also a thing I do on stage when I moderate. I get people out of their comfort zone a bit, because then they actually give much better answers and actually are much more relaxed in giving answers to a moderator, which always gets our marketing department and my manager also like, oh my God, what are you doing? What is he doing? What is he doing? And I'm like, yeah, it's like, you gotta be prepared for everything, I guess. So talking of which, so we now switch over to Raphael to give his talk, because originally we had this like session and then we had hand people over to the talk, and it feels like weird to actually do like 1 hour of talking and then like go into the session. So I want to see what you can teach us here, and then we're going to be discussing afterwards a bit what you talked about. And then when we get time, we get to some more of the resources. But I guess it's a lot of people came because there's a lot of viewers today. So I guess a lot of people came to see your talk. So what are you going to cover quickly to get us into the mood?
So basically, I'm going to cover some design patterns for vector search, including semantic classification, semantic routing, and semantic caching. So one of the challenges today of scaling agentic applications of chatbot is the cost that it takes for you to ask LLMs to compute responses for you, and also the time that it may take to compute this responses, right? So I want to show some patterns that can mitigate these issues. That's basically the idea of this talk.
Cool.
Using vector databases, basically. Yeah.
Yeah, we talked about that earlier. What is a vector database?
So a vector database is a database specialized into storing vectors and retrieving them very efficiently, hopefully, right? So the question is also, what are vectors? I think that's a more important question. I have some slides to explain those. So, and cool. Maybe I can get started with this, or yeah, I can get started with the things that I wanted to share before I came to that quick recap.
Okay. Well, we also have a few other talks that we had by other partners that actually went deep into the vector database stuff and vector explanation. So you can go to the watch section, and we're going to be, when we release this, we're going to send some links around so you don't have to deviate from what you have in your slides that you prepared for this right now. So I think we just hand over to you to actually talk us about the patterns that you want to go through. And then afterwards, we're going to be annoying you again. And as you said, like if we have questions in between, we might be popping up and asking questions because you invited us to do that foolishly, I think. But yeah, we're gonna be seeing what's going on there. So let's hand over to you. Let's share your slides and then Dan and me are going to go backstage and do unspeakable things to your slides while you're presenting them or things like that. We'll see. Cool.
Nice. Thank you.
So let's share your slides and then we go from there.
Nice. So the name of this talk is Reducing LLM Calls with Vector Search Patterns. I have already gave you an idea of what we're going to be talking about. But before we actually get started, I'd like to talk about the Stack Overflow developer survey that came out like 2 or 3 weeks ago. I just wanted to mention that Redis has been selected as the agent data storage tool, the most popular one by the developer community. And this is interesting because if you've built real-time applications before, you've probably used Redis. So Redis has become kind of the foundational infrastructure for real-time applications. And what we're trying to position ourselves today is also as the foundational infrastructure for applied AI applications. Having said that, I'd like to talk about something else. That is, just because you can doesn't mean you should, all right? So GPT-5 was out a couple weeks ago as well. And every time a new model comes out, people say that it's the death of RAG. So you can see in this example, for example, this guy says GPT-5 is out, but it's not a good news to RAG. And the rationale behind it is because, as you can see here, GPT-5 has a context window of 256,000 tokens, which is not something out of this world because we had models with context windows of 1 million tokens before. But the difference with GPT-5 is that even when using all of these tokens, you can still expect the model to produce responses that are accurate and that uses all of the information that you send there. All right, so that's basically the rationale that people use this time to say that GPT-5 is the death of RAG. But the problem is, it's not because you can send 256,000 tokens with every prompt that you should do it, because it may become expensive very easily, right? So GPT-5 takes $1.25 for every million tokens that you that you input, basically. So it would mean that with every 4 requests, you would pay $1.25 to OpenAI, which is not ideal and it's not scalable as well. And this is one of the reasons why I wanted to make this talk as well, because I want to talk about vector search patterns to make agentic applications and also chatbots more efficiently, not only in terms of pricing of the money that we're spending, but also in terms of the time that it takes to process responses or do whatever it has to do. Today, we're going to talk about 3 different patterns. The first one is semantic classification. The second one is semantic routing. And finally, the last one is semantic caching. And we're going to go through 3 different challenges to exemplify how we can use these patterns in our applications. All right, so before we get started actually with the patterns, I'd just like to do a quick recap on vectors and vector search. As it was mentioned, I think the audience is kind of familiar with vectors and vector search. So I'm just going to do something very quick. So basically, when you're talking about text, text has encoded meaning, right? So it has discrete meaning that is not encoded by the characters or the ASCII numbers themselves, right? So one of the challenges computer scientists have had for quite a long time is actually how to encode the meaning behind text. Because if you get something like bad, that means that something is bad, is one definition for it. But if you think about, for example, not bad, it actually means the opposite, right? So how can you encode all the meaning of text? And a couple of years ago, 2013, a couple of researchers at Google DeepMind, if I'm not mistaken, they came up with Word2Vec, which was one of the first embedding models for actually encoding the meaning of words as numerical representations so that computers could work with these numerical representations faster, most efficiently as well. So basically, a vector is a representation, in this case, of a word as numbers that encodes the meaning of these words. And by having those, we can use vector search then to perform mathematical operations on them and understand how similar 2 pieces of text actually are. So you can look at 2 words, for example, and see how similar they are. We can look at 2 snippets of text or even larger text and try to understand if they're similar to each other, if they're synonyms. So if you look at the at the vector representation of the text, did the Apollo 11 crew go to the toilet? And the representation of the text that is, did the astronauts of Apollo 11 went to the bathroom, when you look at those numbers, they should be somehow similar, and this could be seen mathematically so that a computer could understand that these two sentences are actually semantically related. So that's vectors and vector search in a very nutshell. I had prepared some slides for that, but since I understand that the audience is already familiar with that, I just wanted to get everybody on the same page. But I also have these videos so on YouTube. If you want to dive a little bit deeper later on, I invite you all to watch them as well. They're very short, like 3 to 6 minutes, depending on them. All right, so let's talk about the first challenge now, which is filtering posts or filtering text or classifying text. The example that I'm giving here is based on Blue Sky. So we have, like, if you guys are familiar with Blue Sky, it's a social network that is similar to Twitter. So you can post posts there that are up to 300 characters, small ones. And the challenge that I'm bringing here is giving a certain post, how can I classify that it actually belongs to some kind of label? So for example, I get some posts where they're talking about Redis and I want to make sure it's actually about Redis, right? How can I do that? There are different ways of doing that. I know at least 3 ways. One of them is by using an LLM. So you have here a social media post. For example, every repeated LLM call is money on fire. Redis 8 semantic caching understands meaning, not just keys. And what you can do is get the social media post and together with a prompt, send that to the LLM, asking it to return a response in a JSON format, for example, with a property inside of it saying that it's related to Redis with a true or false, and then using that response for whatever your application needs to do. The problem with this approach is that, as I mentioned before, when leveraging LLMs for that, you're going to be paying for the tokens that you're inputting and outputting for that, but also it might take a little while to compute the response for you. So let's say that you're classifying 1 million posts, for example, and each one is taking at least 1 second. You're going to take at least 1 million seconds, if you don't do that concurrently, to compute all of them, right? So this is one of the approaches. And I want to talk about another one that is by using a vector database. But before I actually talk about that one, there's one that is hidden here. I didn't put in the slides, but it's also interesting to talk about, that is by using zero-shot classification models. So those are AI models that are not LLMs. They're a little bit, they're smaller. Actually, they can run locally. They're more efficiently, and they're faster as well. So for example, I have a GIF here. So in this case, we're classifying the text. Java is a great programming language with a few possible labels, such as software programming or politics or something else. And then when you compute that using a zero-shot classification model, it's going to tell us what is the probability that this text actually is related to one of these labels. So that's zero-shot classification models, but this is still using AI. All right, and it may still take a few hundred milliseconds to compute. And that takes us to our third approach here, which is using a vector database. So the way you can classify text with a vector database is by getting a bunch of references. So in this case, I generated all of these references using an LLM, using ChatGPT, for example. I asked ChatGPT to generate 150 tweets about Redis, for example, and it came up with all of them. Here are 4 examples of those. So for example, pro tip, use scan instead of keys in production. Keys blocks the entire server while scan is not blocking, and so on. A lot of those references. And what I want to do with those references that are all related to Redis tweets that mention Redis or that are about Redis, I want to get them. I want to run them through an embedding model so I can turn them, each one of them, into vector representations. And then I want to store these vector representations inside of a vector database, which is Redis in this case. And after I've done that, whenever I get a new post, what I can do is I can run this post through an embedding model as well, the same one, and get the vector representation of this post and run a similarity search in the vector database, Redis in this case, to understand how similar this post is to all the references that I generated and stored inside of Redis. So hypothetically, this one could actually match the closest to this reference that was stored inside of Redis with a similarity score of 0.28. And the similarity score can go from 0 to 1, being 0 the most similar and 1 the most different. And given the threshold that I have defined, so let's say that I say that everything that is below 0.3 is similar enough, I could say, all right, this post is actually about Redis. So I don't have to call an LLM or a zero-shot classification model to classify this text. I can do that with a vector database and a couple hundred references that I have stored in there. And I'm just checking if the post is semantically similar to these references. And if it is, I know that I have classified that correctly, or yeah, correctly, basically. So I have a quick demo to show you as well. Where is it? So this demo is available for anybody who wants to try it. We have this repository, Redis AI resources, on GitHub. We have a lot of recipes for people that want to get started with AI using Redis. And the one that I want to focus on right now is this one, that is basic routing, so semantic routing. So semantic routing is the name of the technique that we're applying here for different use cases. I just saw that my Google Colab preset, so let's see if I'll have to run everything again, or if this is still running. So before I actually show the examples, I also want to talk about the Redis VL library, which is the Redis vector library, which is basically a library that is implemented by Redis in Python. It's also coming to Java and JavaScript to allow people to do semantic caching and semantic routing and vector search with Redis in a more abstract and easier way. And that's what we're going to be using for this example as well. So you can see that here I'm using the route object provided by the Redis VL, the Redis vector library. And here I'm defining a route. The name of this route is technology. And then I have some references here. So what are the latest advancements in AI? Tell me about the newest gadgets, what is trending in tech. And I have the same for sports and entertainment here. So I can classify texts with these routes based on technology, sports, or entertainment. And this is just for the sake of example. That's why we don't have a lot of references, just a couple of them. But what Redis VL is going to do under the hood is basically embed these references, each one of them separately, and then store them inside of Redis alongside the route that they refer to. After we have done that, oh, and there's one more thing. We're also defining the distance threshold here for each of these routes. All right, so let me see if this runs. Okay, I think it just reconnected and everything is still working. Let's find out. All right. And after I've done that, I can then try to classify some text based on this route. So I have here, for example, can you tell me about the latest in artificial intelligence? And if I run this one, it has classified that as technology. It has matched the route technology with the distance of 0.41, which is within the threshold. And it classified that correctly, even though I don't have artificial intelligence written in any of these references. I mean, I have the acronym here, but I don't have the actual words artificial intelligence or any of the words that we have here. I can also try to do something about sports. And I'm sorry for the British people that are watching, but I'm going to use the word soccer here. So can you list a few soccer players? So let's see if this works. Okay, so it matched sports with a distance of 0.68, which is within the threshold. But the reason why I wanted to use soccer here was to showcase that soccer is also not mentioned in any of the references here. We have football, we have sports, but they don't have soccer, and we were still able to match it correctly using semantic routing for classification here. And if I try to classify some text that is not related to any of the routes, as you can see here, are aliens real? It's not going to return any of them because it's not similar enough to any of the references that we have defined inside of our semantic route, basically. So that's semantic classification in a nutshell. Going back to the presentation right now, we're going to talk about the challenge number 2, but I just wanted to ask if anybody has any questions. Not sure. In the comments, maybe. Don't think so.
No questions right now. You can move on.
All right, so let's talk about challenge number 2, that is actually calling the right tools. All right, so when you're working with agentic applications or even chatbots, we can define tools that our LLM can interact with. And the way that it's usually done by most of the frameworks such as Langcache or Spring AI is by defining the tools inside of the prompt. All right, so you define the tools that are available for the LLM to work with, to define the parameters that it may receive, and so on. And then you're going to send this prompt to the LLM, and the LLM may return to you saying, hey, you should call this tool and give back to me the information that it returns. So if you're asking the LLM, for example, hey, what's the weather like? The LLM is stateless, it doesn't have this information, but you say that you have a weather API tool or a get weather function that it may call, it's going to return to your agentic application with the request to call this tool. You're going to call this tool, you're going to get the information that is retrieved from that, and then you're going to send the prompt again to the LLM with this information and all the rest that you had already sent, which means that you're basically computing the same prompt more than once. So you're paying for the same prompt more than once, and you're also taking double the time to process that. All right. And the different approach that we can take here is by using a vector database, by using semantic routes again, but in a slightly different way. So what we can do now is actually come up with some references that may relate to what people would actually ask your chatbot. So for example, what's the weather like? Or will it rain today? Or hello, what can you do? And then get these references to refer to a certain tool. So you can see that the first one is referring to get weather default city. That's the function. Or the what can you do is referring to greeting and help. That's the function it's referring to. And here we're going to do something similar to what we've done before. So we're going to get all of these references. We're going to run each one of them through an embedding model, get the vector that is the result from this embedding model, and store them in a vector database so we can run semantic search later on and see if the prompt of the user or from the agentic application is actually triggering any of these tools based on how similar it is to the references that we have stored in our database. Right, so this is the diagram that shows how it works. So basically, this is the user prompt. Hey, what are you capable of? And then we run that through an embedding model. We vectorize it. We get the vector, and we run a similarity search in our vector database. And then in this case, hypothetically, it has matched the reference, hello, what can you do? With a similarity score of 0.459, which is close enough. It's very similar. And then it means that our application should call the greeting and help function. And all of that without triggering the LLM. All right, so you can avoid triggering the LLM a lot of times by using semantic routing in this case as well. I don't really have a demo for tool calling, but I have another demo here that is for a route that allows you to block or set some guardrails in your chatbot that would work very similarly. All right, so have some blocked references here, for example, and these are, for example, things about extraterrestrials or corporate questions about Agile or anything about the S&P 500. So those are things that you don't want people to interact with their chatbot, and if they do, you don't want to trigger the LLM because you're going to be paying for tokens that are actually not related to your business, right? So you want to block those. Or you want to call tools, as I showed you before. So you can come up with these references. You can come up with a route, as we did before. Let me run this one. And then whenever somebody comes with a question that is related to one of these references, such as what are the results of the Standard & Poor's, which is the S&P 500, you can see that it matched the block list with a distance of 0.44. Even though we don't mention Standard & Poor's here, it could still understand that this is related to the S&P 500. Or for example, I can also ask, is Scrum a great framework to work with? I don't mention Scrum in the references, but I talk about Agile. And since I talk about Agile, somehow my embedding model can understand that Scrum or this sentence is related to one of the sentences in the reference here. Or I could also ask a question such as, how many aliens have visited Earth? And in this case, it was also blocked because we have the reference things about extraterrestrials, and it's similar enough to this reference. Right? So this is semantic routing that can be used for tool calling or blocking references, setting guardrails for your chatbot or your agentic application, so you can avoid going to the LLM a lot of times, and you can avoid spending so much money and also wasting time computing so many responses. Right, so that was the second challenge. And now we have the third challenge, if there are no questions, that is caching the responses. All right, and I have already said that, but basically, or actually gave the examples, but I didn't say that. So let's say that you have a chatbot for your company, and you have a user that asks a question there, and then a couple of minutes later, they come back and ask the same question again. And every time you're sending the prompt to the LLM and computing the response and paying for that. And sometimes for things that you have already computed before that you could just reuse if you cache them. The problem with traditional caching here is that if you cache the actual string and they ask the same question, but with different wording, you're not going to match the cached ones. So basically, the example that I gave, did the Apollo 11 crew, how did the Apollo 11 crew go to the toilet, for example? Or did the Apollo 11 astronauts go to the bathroom? Those are the same questions worded differently, right? So if you use an embedding model and a vector database, you can vectorize these prompts, store them in the vector database, and whenever something similar comes back, you can go to the vector database and retrieve the response from there instead of going to the LLM and computing the same response over and over again. So I have two diagrams here. The first one is showing the regular flow that is basically going to the LLM, asking the LLM to generate the response every time, and now to put in the message. And the second approach is by actually using a vector database and caching that prompt in the vector database. And every time you get a new one, you check if it has already been computed before, as I'm going to show in the demo right now. So this demo is not based on Redis VL. It's actually based on Spring AI. And this one has a more beautiful, or at least a little bit prettier user interface. So what I have here is I have stored inside of Redis, and I can show you that with Redis Insight, a lot of references about beers, basically. So you have the name of the beer and the alcohol of the beer and the description and so on. All of that is stored inside of Redis. So I'm using Redis as a knowledge base here. And we have the actual embedding here. So the vector representing the information that was stored for all of these documents, right? And what I want to do now is I want to ask questions about it. So for example, what kind of beer, maybe that's too small, let me zoom in. What kind of beer goes well with smoked meat, for example? So I can send that. And that's going to take a little while because since I'm asking that for the first time, it's triggering the LLM, and the LLM is going to take a little while to compute it. And I hope it works. It's taking a little longer than it should. Let's take a look at that. Okay, it worked. I think it was, we had some kind of cold start. Shouldn't have taken that long. Usually it would take like 2 seconds to compute that with the LLM. But you can see that the embedding time, so vectorizing the prompt is very quickly, took 10 milliseconds. The searching Redis was very quick as well through the knowledge base, took only 5 milliseconds. But the LLM is usually the bottleneck here because it takes at least 1-2 seconds to compute the response. But now if I ask the same question again with different wording, so what kind of beer goes well with, let's say, smoked beef? And I ask that, you see that the response came back much faster. It's the same response because it was cached inside of Redis using semantic caching. And that took only 25 milliseconds to run through the cache. So it was super fast. And you can also see the cached prompt here in Redis. So let me scan more because we have more than 20,000 here, semantic caching. So we have, for example, this is some tests that I did. Okay, so this is the one that we did right now. What kind of beer goes well with smoked meat? Here's the answer, and here's the vector that represents this text right here, all of these numbers right there.
Can you bump up the font size of the Redis interface a bit? It's really hard to read.
Yeah. Oh, sorry. Okay. Oop, that's too much. All right. Is it better now?
Yes.
Nice. So we have the answer, we have the embedding, so the vector with 384 dimensions, and we have the content that was vectorized here, the semantic caching, and you also have the knowledge base where we have all of the beers, 22,000 types of beers stored in Redis as part of the knowledge base. So this is semantic caching in a nutshell. This is also available for anybody that wants to try it out. We have another repository that is the Redis Spring Boot Resources repository with a lot of recipes there, feel related to AI. So if you want to try it out, feel free to do it. And now that we have talked about these 3 challenges, I want to talk about something else that is optimizing accuracy, because you can imagine that depending on the number of references that you have or the quality of references that you have inside of your database, the accuracy when you're trying to match them may not be good enough. And because of that, our applied AI engineering team has been researching ways of optimizing that. And one of the things they came up with is the Redis Retrieval Optimizer library. It's also for Python. And it has a couple of features here, but basically the idea of this optimizer is to take you from my search seems okay to I can prove this configuration is optimal. Because when you're doing vector search, it's kind of tricky to understand if the embedding model we're using is actually the best one you could be using, or if the results that are being retrieved are the most accurate ones. So this library is, the goal of this library is actually to help you with that. So you can see that the first feature here is to help you systematically test different embedding models and retrieval strategies. So basically, what embedding model should I be using for my vector search, for my RAG, for example? But the one that I want to focus on is the threshold optimization here that allows you to automatically tune the semantic cache and router thresholds. Because I showed you, and where was it? Right here, that when we're defining the routes, we can also define the distance threshold, right? And the way we did it here was mostly by ear, but by getting some test data and sending this data to the optimizer, it can run some optimizations there and come up with the best distance threshold for the routes that you have. So if you run that with this, it can come up with, okay, the best one for technology should be 0.3256, something like that. And then for the second one could be 0.45 and so on. It's going to do that work for you so that you don't have to worry about optimizing it yourself. But there are other strategies that you can apply as well. So if we're talking about semantic classification, for example, one of the things that you can do is self-improvement. So every time you classify a text correctly and you say, okay, this is about Redis, for example, which is what our classification was about, we can add this new post back to the vector database as a new reference to our semantic router. And within time, our semantic router is going to get better because you're going to get more references, and actually references that are not synthetically generated, but that came from real data. So within time, the accuracy is going to increase. But if the accuracy is still not good enough, another approach you can take is a hybrid approach, where basically if something is similar enough, we can say, okay, this is positive. We know that this is about Redis. We're going to move on with that. But if it's not similar enough and we say that it's a negative, we can assume that it may have been a false negative. And in this case, we fall back to the LLM and do the classification with the LLM and check the LLM if it's similar enough or not. Remembering that even the LLM is not going to be 100% accurate. Not even humans are going to be 100% accurate when doing classification, especially at scale. All right. And the best of both worlds here would be the semantic classification with the hybrid approach, but also with the self-improvement. So falling back to the LLM and also adding the posts as new references to the route so that it improves over time. And within time, we rely less and less on the LLM, saving costs and money along the way. So this is the self-improvement, the hybrid approach. So those are ways of improving the accuracy for semantic classification. But what about tool calling? All right. So tool calling, one thing that I tested, especially back in May during Kotlin Conf, was actually how could I improve the accuracy when the users may send prompts that give us a lot of information. Most of this information may not be related to the tool that they're trying to call. So in this case, for example, a user could be, let's say, talking to Alexa and saying, hey, I had a bad day yesterday. The weather was terrible and I crashed my bike onto a tree. Anyway, will it also rain today? And with all of this text, even if we vectorize it and then run a similarity search, it may not be related to anything that we have inside of our database as references because it's kind of random at the end of the day, right? So It can even match something completely different, because when you're running similarity search or vector search, it is always going to return you some response or some vector back from the database. And in this case, you can see that similarity score was too high, meaning that it's very different and that it's actually called the wrong tool here, which is the greeting and help, when it should have called the weather tool. So a way of improving the accuracy that I have researched already is by actually chunking this prompt into separate clauses. So by punctuation, for example. So we get and we chunk that into, hey, I had a bad day yesterday, the weather was terrible and I crashed my bike onto a tree. All of those as separate texts. And then we vectorize each of them separately, and we run them in through the vector database separately. And eventually, and this is wrong, this should have called the weather tool here. One of them, for example, the last one, will it also rain today? There should have been two clauses as well anyway, and will it also rain today? Maybe very similar to will it rain today? That is one of the references, and then we can trigger the right tool more accurately by chunking the prompt into separate clauses as well. So this is a way of improving the accuracy of tool calling. But if you think about it, another caveat that we have here is that if we're using an LLM, we can actually extract parameters from the prompt as well. So all of the examples that I gave here are actually tools that don't require parameters, right? So what's the weather for the default city at today, for example? But there's been a lot of research. This is not the one. This is the one, actually. There's been research on how to use vector databases to extract parameters from text as well. So this is one example that has been done by some people at PwC. But at Redis, we're also making researches to find out how we can improve the accuracy and even make tool calling more effective by using vector databases. Something that I'm looking forward to. And finally, we're talking about semantic caching as well. And one of the problems we can have with semantic caching is when we cache something that shouldn't be cached. Right, so let's say that we have a chat bot that is supposed to tell new jokes, just an example that I thought right now. And you ask it to tell a joke, and it caches the response, and then you ask it to tell a new joke, and then it uses the response that is cached instead of telling you a new joke. So that's something that may happen with their business model as well, depending on what people are asking. You should every time be computing a new response instead of getting one from the cache. And what you can do to mitigate this problem is by combining semantic caching with semantic router as well. So you can define some references that refer to some tools or prompts that shouldn't be cached. And if those are caught by the semantic route, for example, then it would call the LLM every time instead of relying on the semantic caching. Having said that, another problem that may happen with embedding models as well is that, for example, you can ask a chatbot, what's the capital of Paris? And then you cache the response. And then you may ask it, what's not the capital of Paris? And then it gets the cached response because they're similar enough, right? According to the embedding model. So to mitigate that problem as well, Redis has done some research on that. So this is the paper that we have put out back in April of this year, where we trained a specific embedding model, which we've called Langcache Embed v2 here. It's open source. It's available for anybody to use. You can just go to Hugging Face and use it yourself. But the idea of this model is to avoid this kind of examples that I just gave you about the capital of Paris, where they might be very similar, but actually mean something slightly different. And now the last thing that I wanted to talk about is Langcache itself, which is a managed semantic caching service provided by Redis. It's still in the experimental version, but if you don't want to go through the hassle of implementing a semantic caching yourself, you can just go to cloud.redis.io and spin up a semantic cache and use the API. You have libraries as well for JavaScript and Python, I think so far, but more coming within time, that will allow you to cache the prompts of your users with Redis with a service that is fully managed by ourselves. And that's basically everything that I had to share with you today. Again, my name is Raphael de Lio. I've been working as a software engineer in the developer advocacy team inside of Redis. And I hope you have enjoyed the talk. Thank you very much.
Cool. Hang on. Capital of Paris?
Capital, yes.
Capital of France.
Sorry. Oh.
Capital of Paris is the P.
I wonder if I wonder if that proved that I'm not an LLM, or if that proved that I am an LLM.
Can you wave with 6 fingers or something? Or like, it's yeah, I mean, but I thought actually, oh, that's clever. He actually asked the LLM a wrong question and see if he gets the answer. If LLM comes back with like, don't you mean the capital of France? But no,
I meant the capital of France.
It's just an honest mistake. Okay, fair enough.
Yeah, I'm proud of that because it proves that I'm human.
For now,
Good
for
answer.
now. They're gonna clone you anytime, because I mean, the way we describe these things are very, very good. Very interesting approaches to these kind of things. What I find was interesting with this is also a way of, I would love to actually LLMs to get trained better on obvious mistakes that they do. And I mean, these are all mechanisms to prevent you from actually being frustrated by an LLM because it gives you the wrong answer and like these kind of things. But the feedback loop is never there. Like training a new LLM and weighing the new LLM is very expensive. That's why they get rolled out. And when the whole AI thing started, it was rolled out every 2 months, but now it's like every 2 years or every year. So an in-between cache of these things that actually says like, okay, here's the obvious mistakes that this model has, the obvious mistakes that this model has, would be an interesting thing to do. But just saying that, I'm 100% sure people will use it to inject all kind of evil things in there again as well, right?
By using semantic caching, you mean?
Yeah.
What do you mean? I didn't get how it would work for them
as soon as you give a system, when I say like do an in between, that you could actually go to Hugging Face and say like, here's all the mistakes that the obvious mistakes we keep getting from that LLM, but then people will use that to actually inject their answer to like the best browser is ours or these kind of things. So am I just being too blasé about humanity, about doing things evilly? But like, I would love a way to actually make that feature that you said, like make it cheaper for you to use an LLM and not get the wrong answer the second time, to make that available to everybody as well out there. Or in companies. I mean, that would be the other thing, like having a system like that in your company network. So if somebody goes to ChatGPT, it intercepts and says like, by the way, that answer was wrong the last time. Here's the right answer from our database.
That's actually an interesting approach as well. But I think that when companies work with ChatGPT in the enterprise version as well, they interact directly with ChatGPT instead of going through their API, right? I mean, they don't usually build a chatbot using, or they do sometimes, right? I remember now that Harvard, for example, the university, they have a chatbot for their students that helps them getting more credible answers as well. Not sure how well that works. Yeah,
I guess it makes sense because you don't want your people just to basically get into the rabbit hole of talking to ChatGPT all day when they just need to do some research, right?
Yeah. And also, I mean, spending tokens and spending your money with information that is actually not related to your business, right? I think that's the most important thing. So if you create a chatbot for an airline, for example, and people start asking questions about, I know, restaurants, then it's not ideal for your business as well, and you may be spending a lot of money at the end of the day.
Yeah.
Even if you just go to ChatGPT and say, hey, you shouldn't answer questions about anything that is not related to the airline, you're still paying for the tokens to generate that answer. Or if you had that as a semantic route, you could just return a pre-made answer that just says, hey, we don't talk about anything that is not related to airlines here.
And that's nothing new. I mean, I remember when we did like FAQ websites that would be that there were like there were systems that basically said like, okay, that question was asked 15 times by different people. Here's a boxed answer that actually should be getting there. Like we had systems that learned from requests a long time ago, but now we actually say like, okay, like the LLM probably has something new. One thing that I find interesting is how do you prevent a system like that from getting stale? Like when you get a perfectly good answer, for example, is Node.js single-threaded? And yes, it's single-threaded. It's not single-threaded anymore. But basically, how do you tell the system then when you have a cache that you, in the ways that you explained, how can you make sure that like actually this way, this time I don't want that answer, there's something new? How do you refresh that?
So one of the options that we have, so in Redis, if you've used Redis as a cache, you can set a time to leave for your keys. So you can set an expiration time for that. So let's say that we're talking about the weather API, for example, and you cached the information for the day. After the day is done, you want to basically delete that information from Redis so that your LLM or your chatbot or whatever can compute that again and go to the weather API again and go to the LLM again, right? So we can set a time to leave on Redis for weather API, for example, 24 hours or the end of the day, and then the keys cleaned out, basically.
Okay, that makes sense.
Or you can also use, as I said in the presentation, their information that you don't want to cache, right? And then you can use a semantic routing with that as well, or even leave a button for the person to say, give me a new answer instead of using the cached one. In the UI, that's also an option depending on how your users are going to behave, right?
I wondered on that. Just a quick question about who are you finding is kind of responsible for, because it's almost like corralling the not the LLM, but like corralling your own data and kind of keeping it, like you're saying, Chris, not stale, up to date, but also correct. Who sort of has the say over that though? Because I'd imagine if it's just developers adding it onto their job, then you've got, people that maybe disagree with each other, making decisions that conflict. And then, are you finding that there's someone now who has to take that on in the organization as an entire task that they are responsible for every day? Or is it something that you can, visit once a month and kind of knock your chatbot into shape and then revisit it again in a month? Or does it look after itself? How much management is there?
Yeah, that's a good question, right? I don't really have the correct answer for that, but reflecting myself here, I wouldn't give that responsibility to the developers, right? But there should be somebody responsible for the data, maybe data engineers, maybe some stakeholders that go there and see if the data is still up to date. Because building the chatbot is fairly easy, right? And getting knowledge base into vector databases is also fairly easy. But then making sure that the data is still up to date, as you said, is part of what's actually difficult. But not only that, also, as soon as the data is not up to date anymore, how do you actually get you updated? How do you actually get you reindex everything within your vector database, right? In an efficient way.
Now, the Redis is a database that's basically in RAM. It's not writing back to disk. That's why it's actually so much faster. That's why a lot of people are using it for like immediate streaming data, these kind of things, rather than like fixed data like you showed right now, like analyzing a video, for example, and creating analyzing it for content would be easier with something like Redis in memory, rather than just having to have the I/O delay all the time. But that means that actually it's connected to the machine it's currently running on. Is there a way to actually run it in a memory of a centralized server for a company that everybody can access to? Is that the normal way of using it?
Actually, that's the most common way of using it, as a distributed application. So basically, you can even, you have like Redis Cloud. You can go there and create a Redis database for you on the cloud, or do it yourself, host yourself using Kubernetes or something. I think that most people understand from Redis is that since the data lives in memory and you're constantly reading from memory and writing to memory, that the data is not persisted. But that's not true. You can configure, and by default, it's configured to persist the data into the disk. So whenever clients are interacting with Redis, they're going to read and write from memory. But Redis, on a different process, is going to store that data into the disk. So if the application crashes or restarts or whatever, it can restore all of this data back from the backup that it created on the disk. And you can run that You can have that set to run with every command, or every second, or every day, depending on your business model and what kind of information you're storing inside of Redis, right? But another very common way of running Redis is with Redis clusters. So basically, we have multiple instances of Redis, also across different regions. So if you have clients in different parts of the globe, you can serve them faster by using active instances within Redis cluster as well.
Cool. So
but
you can
usually,
save, so all the money you save by not using up your tokens, you can actually spend on Redis Cloud.
That's maybe, yeah, depending on your use case, how fast, because it's not just the money, it's also the speed, right? As I told you before, I didn't say in this talk, we have a customer, for example, that has 80 terabytes of vectors stored inside of Redis. So when you think about Redis and that it runs in memory, it might be kind of mind-blowing to think that somebody's storing that much inside of Redis. But it's also very critical for their business case, because they need to retrieve these vectors not only accurately, but also very fast. And that's why they opted for Redis Cloud in that case.
And
but you can run Redis cluster yourself as well. We don't have to rely on Redis Cloud if you want to manage it with your
as a
DevOps
software
team.
provider, you want customers like that are basically the outliers that really, really punish your system with like 80 terabyte of data, like, because you see, first of all, how far it scales, but also you can then, as a DevRel person, go up to them and say like, hey, what did you do to make that happen? Because that's a great story to actually analyze and see where it scales to other people. But it's fascinating because we always try to scale to infinity everything we start from the beginning, and we over-engineer and we over-architect things that way. But it's great to hear these stories that basically they're getting there, but also just the idea of being able to clean up the things rather than using up your tokens for bad answers or like nonsensical answers is a very, very nice thing. And thanks very much for all these things that you said here, because they're all independent of Redis as well. You can use them with any other vector database that you want to. It's basically just recipes. You said you have a recipe collection on the Redis GitHub repo. Is that something that can be just accessed by anyone?
Yes, totally. We have two. We have one that is the Redis AI resources repository. Maybe I can send you the link here. And the other one is the Redis Spring Boot resources. So the Redis AI resources repository is mostly used. Where do I send it, in the private chat?
Just send it an email afterwards so that we can then show it
right.
through the recording. Don't worry.
Okay. So the Redis AI resources repository is full of recipes using the Redis VL, this library for Python that I showed you. And the Redis Spring Boot resources is a lot of recipes, not really related to artificial intelligence, even though a few of them are. But for Spring Boot, basically. So using Spring AI or Redis on Spring, which is an open source library that we have to support Spring Boot users as well.
Cool. Well, I mean, the hour is over. We're kind of over time, and we didn't get any of the resources, but that's totally fine because there's a lot of information that came out of that one. And as said, it's applicable to everything. You don't need to use Redis. You can use other things as well, but I think it's open source, so it's great to support. So that's always the thing that I find interesting here as well. And it's fascinating to see that we're in a world where people ask you to actually go AI first and just use third-party systems for everything. But there is a way for developers to fine-tune and to hone the results and make sure that we're not actually just wasting. Because a lot of times I find that developer convenience and also researcher convenience is currently sold as a veiled attempt for subscriptions. So instead of just like burning through your tokens within the first day of research, it's a great opportunity to set up a system like that to save yourself from having to spend more and more money for information that you don't have. We had a guest here some month ago from Reuters, a researcher, and they actually have a system internally where they have different models and different cloud providers where they compare, and they actually, with every research that they do, it shows them how much it costs the company. And then they compare it with each other to see like how to optimize the spending of the company. I think that's a very, very clever way to do these kind of things as well. Cool. Anything else from you, Raphael? Where do we find you? What do you want to know from people that you normally don't get as requests?
So you can find me on LinkedIn. I'm on LinkedIn. I'm on YouTube. I have my personal YouTube channel. I also create videos on Redis YouTube channel as well. I'm on Blue Sky. I'm on Twitter. I'm on GitHub, Medium, everywhere. Basically, you can find me. Just Google my name and something will pop up. Hopefully something that is not
something good.
Yeah.
So Dan, any last words from you for our people that are on the feed and in the recording?
Very quick one, just to say, if you haven't already, go to wearedevelopers.com, click on watch at the top, and there are hundreds and hundreds of new main stage talks from the World Congress that you can go and watch. So you can watch talks from the World Congress probably until the next one, to be honest. There's that many videos on there. You can just watch them. So yeah, just wanted to plug that. Go and check them out. We're going to have a lot more coming as well in the coming weeks. And yeah, that's enough from me.
Well, thanks very much. I mean, Rafa, you obviously have to tend to the dog now because he's already cooking there. So we leave you at that. And thanks for watching and thanks for being part of this. We see you next Wednesday where I'm going to be in Vienna. So I'm going to be in the nice office again. And yeah, I'm also going to be coming to America. So if any of you is watching that later on in October, I'll be at the All Things Open conference in Raleigh, North Carolina. So make it worthwhile for me to fly over there and hopefully see you there. Other than that, newsletter is what I'm working on right now. That's going to be out on Friday again. If you haven't subscribed to that, what's wrong with you? And generally, we are going to be talking next week again with a good guest and have more information and more resources for you to go through as well. Thanks very much. Bye-bye.